Up until now, we have a couple ways to solve our limit problems. The first way I always like to try is try and plug in the number right away, see what you get. So when we plug in 0, we get 0 squared times the sine of 1 over 0, which is equal to 0 times the sine of infinity. And with that, we don't really have another option. We don't really know where to go from there. So let's go back. Another way we know how to solve a limit is we can try and factor. There's no factoring here. We can try and take the conjugate. There's no way to take a conjugate here. So on this one, we're going to have to pull something out of left field. What we do know about this is we know that we have the sine function. So we know that the sine function is going to oscillate, and it's never going to get larger than 1, and it's never going to get smaller than -1. So now that we have this, we want to try and get our original equation, x squared times sine of 1 over x. So let's go ahead and multiply each part by x squared. Since we're multiplying each part, we're not really necessarily changing anything. So we will have negative x squared is less than or equal to x squared sine of 1 over x, which is less than x squared. And now we can go ahead and take the limit of each of these parts. So we'll have the limit as x approaches 0 of negative x squared is less than the limit as x approaches 0 of x squared sine 1 over x, which is less than or equal to the limit as x approaches 0 of x squared. So we know how to evaluate this guy right here. So we can plug in 0 and we get the limit as x approaches 0 is 0. We still don't quite know what this is because this is our original problem. So we'll rewrite that. The limit as x approaches 0 of x squared times the sine of 1 over x less than, and we can evaluate that guy. When we plug in 0, we get 0 squared, so that's also going to be 0. So what we see here is we have our original function, and we see that it has to be less than 0, and it has to be greater than 0. So by the squeeze theorem, this is saying that the limit of x squared times sine of 1 over x as x approaches 0, this has to equal 0. We can see this by graphing it. Let's say we draw this coordinate plane. If we were to graph x squared, something like this, and negative x squared, we see that as x approaches 0 for both of these, we have 0 right here. And since we know our function, x squared times sine of 1 over x, is always going to be less than or equal to it and greater than or equal to it, as we see right here, we know by the squeeze theorem that x squared times the sine of 1 over x, the limit as it approaches 0, also equals 0. It literally squeezed it between the two functions. That's the squeeze theorem.